Welcome to the DIY Honda Garage channel. The trouble codes P0301 to P0306 indicate that there is a misfire detected in one or more of the 6 cylinders of the Honda Odyssey 2011 to 2017 models. A misfire occurs when the air-fuel mixture in a cylinder does not ignite properly, which can lead to reduced engine efficiency, increased emissions, and potential engine damage. Each code corresponds to a specific cylinder, with P0301 indicating a misfire in cylinder 1, P0302 in cylinder 2, and so on, up to P0306 for cylinder 6. Misfires can be caused by various issues, including ignition system faults, fuel system issues, or mechanical problems within the engine itself. The onboard diagnostic system, known as OBD, onboard diagnostics, records these misfires and stores the respective codes for troubleshooting. Early identification and resolution of misfire issues are crucial to maintain engine performance and overall vehicle reliability. The components affected by DTC P0301 to P0306 are the engine cylinders, namely cylinders 1 through 6, located within the engine block of the Honda Odyssey. Each cylinder is crucial for the combustion process, where the air-fuel mixture ignites and produces the power needed to propel the vehicle. Inside each cylinder, there are several crucial parts, including the spark plug, fuel injector, and piston. The presence of a misfire means that one or more of these components are not functioning as intended, leading to incomplete combustion. Additionally, poor combustion can result in engine vibration, increased exhaust emissions, and potentially impact fuel economy. Proper diagnoses depend on monitoring these cylinders closely through the vehicle's onboard diagnostic system, which can provide valuable data regarding individual cylinder performance. There are several possible causes for the misfire codes P0301 to P0306. Ignition system faults, such as defective spark plugs or faulty ignition coils, can prevent the necessary spark from igniting the air-fuel mixture in the cylinders. Fuel delivery issues, including clogged fuel injectors or a failing fuel pump, can also lead to inadequate fuel being supplied to the engine, causing misfires. Furthermore, vacuum leaks can disrupt the proper air-fuel mixture needed for combustion, contributing to the issue. Each of these causes can disrupt the engine's performance, resulting in the misfire codes being triggered. It's essential to systematically evaluate these potential causes to pinpoint the exact issue affecting the vehicle's engine performance. The symptoms associated with DTC P0301 to P0306 generally reflect engine performance issues. One prominent symptom is rough idling, where the engine may vibrate or run unevenly when at a stop. This is typically due to one or more cylinders failing to ignite correctly. Additionally, the driver may experience reduced engine power, especially during acceleration or while driving uphill, as the engine struggles to produce the necessary force. Increased fuel consumption is another notable symptom. If the combustion process is inefficient due to misfires, fuel is wasted. Other possible symptoms might include the check engine light activating and potential engine noises that indicate mechanical issues. Awareness of these symptoms can encourage timely troubleshooting and repairs. For the first troubleshooting step, ensure that the vehicle's ignition switch is turned to the on position, specifically to position 2. This allows the onboard diagnostic system to power up and prepare for diagnostics. Before proceeding, it is also necessary to record all freeze data. This data captures the engine conditions at the time the trouble codes were triggered, which can be crucial for understanding the circumstances surrounding the misfire. Additionally, reviewing the general troubleshooting information is essential, as it provides context and background knowledge that can aid in identifying the underlying issue. This preparatory work forms the foundation for effective troubleshooting and enhances the chances of accurately diagnosing the problem. In the second step, use a Honda Diagnostic System, HDS, to clear the Stored Diagnostic Trouble Codes, DTCs. The HDS is a specialized tool used to communicate with the vehicle's onboard computer, allowing for data retrieval and clearing of codes. This step is pivotal as it resets the DTCs, enabling the technician to monitor the vehicle's current performance without old data interfering. After clearing the codes, start the engine and allow it to idle for a period of 2 minutes. This idling time lets the engine stabilize and provides an opportunity to observe the OBD status for the error codes to reappear. Clearing the DTCs is critical for accurate diagnostic results and helps to identify whether the issue is ongoing or resolved. In the third troubleshooting step, after starting the engine, allow it to idle for 2 minutes without any load, meaning the vehicle should be in park, P, or neutral, N. This idling period is essential for stabilizing engine conditions and allows the onboard diagnostics to gather relevant data regarding the engine's performance. During this time, monitor the onboard diagnostics OBD status using the HDS, specifically looking for the appearance of the DTCs P0301 to P0306. If the HDS indicates failed, it is a clear sign that the misfire condition still exists and further diagnosing is required. On the other hand, if it shows passed, it suggests that the issues may have been temporary, while indications of executing or out of condition require further idling or parameter checks before proceeding. In the fourth step, utilize the HDS to examine the misfire status for each cylinder within the data list. Specifically check the counts for CYL1 through CYL6. This data reveals how many misfires, if any, have been recorded for each cylinder during the idling process. This information is crucial for identifying which specific cylinder or cylinders are having issues. If any cylinder shows misfire counts, it indicates that the problem persists and further steps need to be taken. Should none of the cylinders show misfire counts, it suggests that the misfire occurrence might be intermittent, warranting a more detailed investigation into possible connection issues or faults in the fuel and ignition systems. For the fifth step, take the vehicle on a test drive for several minutes, ensuring that the driving conditions encompass the recorded parameters from the freeze data. This includes monitoring conditions such as engine speed, vehicle speed, and engine coolant temperature, among others. During the drive, it's crucial to reproduce the operating conditions under which the misfire errors were recorded, as this will give clearer insight into whether the issue recurs in a practical scenario. After the test drive, use the HDS again to monitor the OBD status for the misfire codes. This dynamic test can reveal whether environmental variables or driving conditions influence the misfire, providing additional data for accurate troubleshooting. In this sixth troubleshooting step, again monitor the OBD status using the HDS following the test drive. Check to see if the system displays a failed status for any of the misfire DTCs P0301 to P0306. A failed indication means that the misfire issue is still present and further troubleshooting will be necessary, potentially returning to step 8 of the diagnostic process. Alternatively, if it indicates passed, it implies that the misfire condition seems to have rectified during the driving conditions. It's important to consider also the outcomes of executing and out of condition, which suggest that the diagnostics need further time or specific conditions to yield results before conclusions can be drawn. During this 7th step, check the misfire counts for CYL1 to CYL6 once more via the HDS, after the driving tests have been completed. This is similar to the previous assessments of cylinder misfires, but is crucial to confirm if any cylinder has shown repetitive issues during the test conditions. If any cylinder reflects misfire counts, it indicates that the misfire is still occurring, and the next logical step is to troubleshoot further. If, however, the misfire counts show no activity, this may indicate an intermittent failure. In such instances, it can suggest a temporary fault or connection issue that requires thorough investigation into the fuel system and ignition system components. If the previous checks reveal no misfire counts, it suggests that the misfire problem may be intermittent rather than a consistent issue. In this 8th step, it is critical to delve deeper into system checks, specifically looking for poor connections or loose terminals in both the fuel and ignition systems. Such irregularities can lead to inconsistent performance of the fuel injectors or spark plugs, resulting in intermittent misfires. Thoroughly inspect wire harnesses, connectors, and components for signs of wear or poor connectivity. Addressing these connections can significantly enhance the overall performance and reliability of the engine, ensuring proper operation and preventing future codes from arising. In the final step of troubleshooting, turn the ignition switch to the lock position, known as position 0, to ensure the vehicle's electrical systems are powered down. This step signifies the completion of the diagnostic process, allowing for a closed assessment of any findings from the troubleshooting activities. After performing all steps, compile any findings or repairs made during the procedure for record keeping and to inform any future services. This systematic approach helps in addressing all potential issues related to cylinders misfires effectively, so the vehicle operates reliably and efficiently moving forward. After completing all necessary repairs based on the troubleshooting steps, it's essential to carry out a final verification process. This involves confirming that all repairs made were indeed effective in resolving the misfire issues. After this verification, use the HDS once again to recheck for any DTCs. If no misfire codes appear, it is a strong indicator that the repair has been successful. Additionally, further road testing may be advisable to ensure that under various driving conditions, the vehicle maintains optimal performance without triggering any misfires. This final verification step is crucial to provide assurance of the repairs made and ensure the reliability of the vehicle moving forward. Conducting regular diagnostic checks is an essential preventive maintenance step to mitigate issues such as those indicated by DTC P0301 to P0306. Frequent diagnostics can catch potential problems early, preventing them from evolving into more significant concerns. Keeping a close eye on crucial engine components, such as spark plugs, fuel injectors, and electrical connections, can also serve as proactive measures against misfires. Regularly scheduled oil changes and fuel system cleaning help maintain engine health and efficiency. Establishing a systematic maintenance schedule, including visual inspections for wear and tear, ensures that the engine operates smoothly. These practices not only enhance the vehicle's performance, but also prolong its lifespan. In conclusion, understanding and effectively troubleshooting DTC P0301 to P0306 is essential for maintaining the performance of the Honda Odyssey from 2011 to 2017. Identifying the underlying causes of cylinder misfires early is crucial, as it prevents further complications and ensures timely repairs. Following a systematic approach, including detailed checks and monitoring through the Honda Diagnostic System, HDS, aids in addressing the misfire issues efficiently. Regular maintenance and preventive checks are equally important. They help keep the engine in good condition and reduce the likelihood of misfire occurrences. Through diligent troubleshooting and proactive care, vehicle reliability can be significantly enhanced, ensuring smooth operation and optimal performance over time. Please like and subscribe to the channel. See you next time!